Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 17. In this video we will discuss about data transformation in pandas. In the previous video, we discussed data preparation from data manipulation. Today we will discuss about data transformation. So in this tutorial we will discuss about all these 8 things from data transformation. Alright, first we will know something about data transformation. Data transformation, so far you have seen how to prepare data for analysis. This process in effect represents a reassembly of the data contained within a data frame, with possible additions by other data frame and removal of unwanted parts. Now begin with the second stage of data manipulation, the data transformation. After you arrange the form of data and their disposal within the data structure, it is important to transform their values. In fact, in this section you will see some common issues and the steps required to overcome them using functions of the pandas library. Some of these operations involve the presence of duplicate or invalid values, with possible removal or replacement. Other operations relate instead modifying the indexes. Other steps include handling and processing the numerical values of the data and also of strings. So now we will see in practically. First we will know about removing duplicates. Duplicate rows might be present in a data frame for various reasons. In data frames of enormous size, the detection of these rows can be very problematic. Also in this case, Pandas provides us with a series of tools to analyze the duplicate data present in large data structures. First, create a simple data frame with some duplicate rows. Now we will execute once. And you can see the output. The duplicated function applied to a data frame can detect the rows which appear to be duplicated. It returns a series of booleans where each element corresponds to a row, with true if the row is duplicated and with false if there are no duplicates in the previous elements. As you can see, the output as booleans form. So now you can see the difference between these two output. The fact of having as the return value a Boolean series can be useful in many cases, especially for the filtering. In fact, if you want to know what are the duplicate rows, just type the following. As you can see here we got 2 duplicate rows. So you can see here. Generally, all duplicated rows are to be deleted from the data frame. To do that, pandas provides the drop_duplicates function, which returns the data frame without duplicate rows. Now you can see here we got frame without duplicate. Now we will know about mapping. The pandas library provides a set of functions which, as you shall see in this section, exploit mapping to perform some operations. The mapping is nothing more than the creation of a list of matches between 2 different values, with the ability to bind a value to a particular label or string. To define a mapping, there is no better object than dictionary objects. So this is the dictionary, as you can see here. The functions that you will see in this section perform specific operations, but all of them are united from accepting a dictionary object with matches as an argument. Replace function replaces values. Map function creates a new column. Rename function replaces the index values. Now we will know about replacing values via mapping. Often in the data structure that you have assembled there are values that do not meet your needs. For example, the text may be in a foreign language, or may be a synonym of another value, or may not be expressed in the desired shape. In such cases, a replace operation of various values is often a necessary process. Define, as an example, a data frame containing various objects and colors, including 2 colors that are not in English. Often during the assembly operations is likely to keep maintaining data with values in a form that is not desired. Now you can see the output. Thus, to be able to replace the incorrect values in new values is necessary to define a mapping of correspondences, containing as key to replace the old values and values as the new ones. Now the only thing you can do is to use the replace function with the mapping as an argument. And after replace the value, you can see the output. As you can see from the result, the two colors have been replaced with the correct values within the data frame. A common case, for example, is the replacement of the nan values with another value, for example 0. Also here you can use the replace, which performs its job very well. Now you can see here nan value replaced 0 instead of nan. Now we will know adding values via mapping. In the previous example, you have seen the case of the substitution of values through a mapping of correspondences. In this case you continue to exploit the mapping of values with another example. In this case you are exploiting mapping to add values in a column depending on the values contained in another. The mapping will always be defined separately. Now here we delete the price column, because later we will add this column externally. So now we have only two columns here. As you can see the output. Let's suppose you want to add a column to indicate the price of the item shown in the data frame. Before you do this, it is assumed that you have a price list available somewhere, in which the price for each type of item is described. Define then a dictionary object that contains a list of prices for each type of item. Now we will declare a price. The map function applied to a series or to a column of a data frame accepts a function or an object containing a dictionary with mapping. So in your case you can apply the mapping of the prices on the column item, making sure to add a column to the price data frame. Now you can see the output after adding the price. Now we will know about how to rename the indexes of the axes. In a manner very similar to what you saw for the values contained within the series and the data frame, even the axis label can be transformed in a very similar way using the mapping. So to replace the label indexes, pandas provides the rename function, which takes the mapping as argument, that is, a dictionary object. Alright, now you can see the index after renamed. As you can see, by default, the indexes are renamed. If you want to rename columns, you must use the columns option. Thus this time you assign various mapping explicitly to the two index and columns options. Now you can see the output. Column's name has been changed with re-indexed. Also here, for the simplest cases in which you have a single value to be replaced, it can further explicate the arguments passed to the function of avoiding having to write and assign many variables. And again you can see the output, in another way. So far you have seen that the rename function returns a data frame with the changes, leaving unchanged the original data frame. If you want the changes to take effect on the object on which you call the function, you will set the InPlace option to true. Now you can see the output. Now we will know about discretization and binning. A more complex process of transformation that you will see in this section is discretization. Sometimes it can happen, especially in some experimental cases, to handle large quantities of data generated in sequence. To carry out an analysis of the data, however, it is necessary to transform this data into discrete categories, for example, by dividing the range of values of such readings in smaller intervals and counting the occurrence or statistics within each of them. Another case might be to have a huge amount of samples due to precise readings on a population. Even here, to facilitate analysis of the data, it is necessary to divide the range of values into categories and then analyze the occurrences and statistics related to each of them. In your case, for example, you may have a reading of an experimental value between 0 and 100. These data are collected in a list. You know that the experimental values have a range from 0 to 100, therefore you can uniformly divide this interval, for example, into 4 equal parts, such as bins. The first contains the values between 0 and 25, the second between 26 and 50, the third between 51 and 75, and the last between 76 and 100. To do this binning with pandas, first you have to define an array containing the values of separation of bin. The object returned by the cut function is a special object of categorical type. You can consider it as an array of strings indicating the name of the bin. Internally it contains a levels array indicating the names of the different internal categories and a labels array that contains a list of numbers equal to the elements of results. The number corresponds to the bin to which the corresponding element of results is assigned. Now you can see here, interval index as output. Just see this output, later we will explain. Finally, to know the occurrences for each bin, that is, how many results fall into each category, you have to use the value counts function. Now you can see here we got how many results fall into each category. Now see here we try to find how many result falling in between 75 to 100. So that's why here we got 5. And similarly rest of the result worked in same way. As you can see, each class has the lower limit with a bracket and the upper limit with a parenthesis. This notation is consistent with mathematical notation that is used to indicate the intervals. If the bracket is square, the number belongs to the range, limit closed, and if it is round the number does not belong to the interval, limit open. You can give names to various bins by calling them first in an array of strings and then assigning to the labels options inside the cut function that you have used to create the categorical object. As you can see the output. If the cut function is passed as an argument to an integer instead of explicating the bin edges, this will divide the range of values of the array in many intervals as specified by the number. The limits of the interval will be taken by the minimum and maximum of the sample data, namely, the array subjected to binning. Now see the output. In addition to cut, pandas provides another method for binning, qcut. This function divides the sample directly into quintiles. In fact, depending on the distribution of the data sample, using cut rightly you will have a different number of occurrences for each bin. Instead qcut will ensure that the number of occurrences for each bin is equal, but the edges of each bin to vary. As you can see, the output Q cut and value count. As you can see, in the case of quintiles, the intervals bounding the bin differ from those generated by the cut function. Moreover, if you look at the occurrences for each bin, will find that qcut tried to standardize the occurrences for each bin, but in the case of quintiles, the first two bins have an occurrence in more because the number of results is not divisible by 5. Now we will discuss about detecting and filtering outliers. During the data analysis, the need to detect the presence of abnormal values within a data structure often arises. By way of example, create a data frame with 3 columns from 1000 completely random values. Let's see the example. Now you can see the frame here. With the describe function you can see the statistics for each column. Now you can see here we got many type of output like count, mean, std, min, max, etc. for each columns. For example, you might consider outliers those that have a value greater than 3 times the standard deviation. To have only the standard deviation of each column of the data frame, use the std function. Now you can see the standard deviation for each column. Now you apply the filtering of all the values of the data frame, applying the corresponding standard deviation for each column. Thanks to the any function, you can apply the filter on each column. As you can see the output. Now we will know about permutation. The operations of permutation, random reordering, of a series or the rows of a data frame are easy to do using the numpy random permutation function. For this example, create a data frame containing integers in ascending order. As you can see the frame. Now create an array of 5 integers from 0 to 4 arranged in random order with the permutation function. This will be the new order in which to set the values of a row of data frame. Now you can see the new order with permutation. Actually, this is a row index order. Now apply it to the data frame on all lines, using the take function. Now you can see here, the row index is arranged according to permutation order. As you can see, the order of the rows has been changed. Now the indices follow the same order as indicated in the new order array. You can submit even a portion of the entire data frame to a permutation. It generates an array that has a sequence limited to a certain range, for example, in our case from 2 to 4. Now you can see here, here we got a portion of the entire data frame to a permutation. Alright, now we will discuss about random sampling. So you have just seen how to extract a portion of the data frame determined by subjecting it to permutation. Sometimes, when you have a huge data frame, you may have the need to sample it randomly, and the quickest way to do this is by using the numpy random randint function. Alright, so let's execute once. Now you can see here we got a random number, and keep your mind one thing, how many time we execute this program, then each time generate a random number. Alright, now we will use take function. Now you can see here we got only those rows, which we have in sample. And you can see each time we get random rows. So friends, our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe our channel, and don't forget to like and share the video. Thank you.